Hello, lovely people. Can everybody hear me okay? Hello, Resurrection Stone. Hi, Fassi. Hi, Momina. Bonjour, Chilaj. I hope everybody's managed to grab the slides. They're in the description, so just keep in mind, usually they're in the description a little bit before the class starts, so you can always print them off like 10 minutes before. So that you don't have to like do that while the class is actually running. Hello, how's everybody doing? Apologies for last week when everything was cancelled. I was not very well, so sorry about that. Thank you, Namrat. I'm feeling so much better. Hello. Yeah, Cleo, I was ill. We didn't have any cover. We have found somebody that will do cover in the future, hopefully when I'm ill. So hopefully it won't happen again. But yes, I wasn't very well. So thank you for bearing with us for that. What we're going to do is alkenes today. If you haven't been here before, welcome. My name is Georgia. Is this free? Yes, it is. It's free because it's on YouTube. I'm sure I will get ill again at some point, Jalaj, it happens, but like hopefully it won't be on a YouTube day. But yes, so the idea of these is essentially that we sort of run through some exam questions. So I'll put the exam question on the screen. I'll give you like an appropriate length of time to have a go at it yourself. And please do have a go at it yourself because, you know, like you're practicing answering questions will help you a lot more than just sort of listening to somebody else answering them, I promise. And then I will go through them and you have a chance to ask me any questions you have. And this is a year 12 topic at the moment. So this is, that is the plan. So I'm gonna share the presentation with you guys on the screen so that we can get started. It's a good question there. Has anyone started personal statements? It's a good thing to start thinking about. You guys have got loads of time now. Personal statements are a great thing to be thinking about at this point if you are a year 12. Okay. Also, I'm super excited about these dinosaurs that I found. This is a reading dinosaur. I think chemistry, there's not much opportunity for like cute things. So the dinosaurs are my jam. All right. So at the end, we're going to sort of give you a coupon code for our website. So sort of stay tuned for that if you would like to have a look around our website. We're also going to be doing that at the end as usual. Chemistry itself is cute. I'm not really sure if you can call it cute. I see what you mean though. It's cool. Yes. Okay. So like I know lots of you are freaking out about your personal statements, especially medics. So we've actually been doing personal statement workshops on our platform rather than on YouTube. So that's something that if you wanted to sort of have some help with, you might think about signing up. But yes, let's get started. So the first question, we've got sort of like the first few questions are multiple choice, and they're all about sort of our polymer stuff in terms of alkenes. So the first question says, what is the formula of polybutanene? So you got like 1 minute to decide. Have a look. And those of you who are saying you can't get work experience for med, so on some of the med school websites, what they have said is that if your work experience is cancelled, just make sure you do it before the interview if lockdown is lifted, obviously. Also do a bunch of stuff online that you can do online in the time being, right? You've not missed anything really. I just introduced myself, KF. This should be about 45 minutes to an hour, depending on, I'm aiming for 45, but it often runs over by like 5-10 minutes or 15. Yes, no more than an hour. It's okay if you don't know the answer, Dominic. Just try working through what you can, and then I'll explain the answer in about 30 seconds. I have seen that suggestion of our RCGP for online work experience. I haven't checked it out myself though. You could also try sort of all of the schemes to like help out local people. So I know there are some sort of schemes related to different areas where you call lonely people during this time. That is an example of sort of caring work. So that might be a good idea to volunteer to try and do that with your local council, stuff like that. All right, okay, I'm going to tell you the answer, and the answer is B. So just as a quick reminder, we have polybutanene, which means that we have butanene. So you guys should remember that butanene has a double bond between the first two carbons. And I'm not going to draw my hydrogens because I'm lazy, unless anybody desperately wants me to. And so we know that the polymer bonds are going to form between these first two carbons, right? So because the polymer bonds form between the first two carbons, then it's those two carbons that are sort of in the formula, the general formula for butanene, and then the next two sort of have to be off the side. So I hope that makes sense to everybody. So that is why it is B. Feel free to ask any questions. Is everybody cool before I move forwards? You work in a pharmacy, is that caring enough? Yeah, I'm going to agree with Sard and say that it depends how you, what kind of story you tell about that experience in your personal statement. The chemistry ones are on Tuesdays and Thursdays, but we have other subjects on other days. Because it's an ethyl group. What do you mean, Jalaj? Because it's an ethyl group. Do you mean like the last two carbons are the ethyl? So if the carbon is branched off, then it's an alkane. Yeah, so any sort of hydrocarbon that is just carbon and hydrogen with no double bonds, only single bonds, is an alkane. Is it B because of that? Yeah, it's B because butanene has 4 carbons, and only 2 of those, so the ones with the double bond, are going to be the ones that sort of, I'm going to highlight them actually. So these 2 carbons are these 2 on B, and these 2 carbons are the ethyl group on B. It's the double bond that forms the polymer bonds, so that one, so everything else has to be sort of off the side. Does that make sense, Jalaj? Yes, no, maybe. Let me know if it doesn't, and I'll go back, but I should probably, yeah, it does. Okay, wicked. All right, so another multiple choice question about our polymers. So this question says, a section of polymer is shown below, and it's asking us what the monomer is of this polymer. So remember that you are looking for the repeating subunit. That's what a monomer is, a repeating unit. And remember that the monomer, if it's an addition polymer, must be something really specific. I'm going to give a couple more people some time to have a look, and then I will just go for it. I'm getting lots of A's and lots of C's. And what that tells me is that all of you have recognized the repeating subunit. So you can see that the repeating subunit is sort of this here. It kind of chops down the middle. It repeats again. But the monomer must be the alkene. So remember that this is an addition polymer, and we can tell that it's an addition polymer because it doesn't have any of the things that some kind of condensation polymer would have. So it doesn't have an ester group, it doesn't have an amide group, so it must be an addition polymer. So in that case, we know that it's formed of alkenes. So the monomer has to also be an alkene, so it needs to be C, right? Does anybody have any questions about that before I move forwards? I'm not. Is it possible to increase the font? It isn't for this specific class, but if it's too small, I can in future increase the font. So I apologize, Kasumba, if it's really hard to watch. Can I go over? Yes, I can go over all of those things. Yes, and my colleague has just dropped the links to the slides. So that's a PDF that you could zoom into. Yeah, I apologize. The presentation isn't very accessible if it's hard to see. So I apologize about that. So scrolling up, why does the double bond go away? Okay, so the double bond goes away because it's an addition polymer. And I'm really quickly going to talk about addition polymers because that seems to be quite, seems to be one of the things that a lot of us are a little bit confused about. So addition polymers are the kind of polymers that are formed when you have, are the kinds of polymers that are formed when you have a double bond causing polymerization. So in this case, I'm going to start from C and work backwards. So if I had this alkene, this alkene next to the same alkene, they can join together in a reaction to form a longer chained alkane. So what happens is both double bonds break. So I'm going to show the first double bond breaks. I'm going to delete that and may form a link with another alkene next door. And this double bond breaks and can form a bond with the alkene we see on the screen. And then the next double bond will break and form a bond with this alkene, and so on until you get this long chain where all of the double bonds are broken and you just have a long chained alkane. That's an addition polymer, and we call it an addition polymer because it's an addition reaction. So if you remember, addition reactions are reactions where a double bond is broken to form more single bonds. Does that make sense? Why we have an ethene as the monomer? Does that, let me know if that's making sense to you guys. Then the next question was, just curious, is D and E, is D an isomer? Yes, D is an isomer. D is definitely an isomer. You're right, Judge. Is condensation polymerization on AQA? Yes, it is. It's just in the year 13 section. So if you've not heard of condensation polymerization, that's okay. It's not what we're testing you on. I just wanted to make sure that anybody that has covered it knows why this is addition instead of condensation. So is everything, so addition polymerization is on all of the specs. You may, so usually teachers cover addition polymerization right at the end of the year in year 12. So some of you just may have missed that, but it's definitely year 12 and it's definitely on all of the specs, I promise. Is it only alkenes that can undergo addition polymerization? In A level, yes. In real life, you can also have alkynes. Alkynes look like this. They have triple bonds and they can also undergo addition polymerization. But you don't need to know that for A level. Is there a catalyst or conditions you need to know? No, nope. does AQA cover condensation polymerization? Yes, in year 13. So you'll see it under like the amino acids stuff. When you learn about amino acids and proteins, that's all condensation polymerization. You're in you're year 11, can you still join the live streams? Of course you can, Palumi. But the problem is that you might not sort of know what's going on. So they're not really teaching sessions. They're sort of like, we do questions together. So you might get a bit confused, but you are welcome to join. Is there a question on sigma and pi bonds? No, there's not. Can I send a written version after the session? No, we don't share the sort of ones that are written on. So you either need to make notes or screenshot. But I'm going to continue. Okay, next question. So we're still on addition polymerization. And this question shows a repeat unit of the polymer shown below, and it's asked to give the systematic name of the alkene monomer that forms this polymer. So we're looking for the name of the monomer. So remember from the last question, the monomer must be an alkene. So keep that in mind. You've got about a minute to come up with it. And I also, oh, right. The people that said the writing was too small for the last slide, is this a better size? Can you see it properly? It's still quite small. Okay. I suppose because you can't really make it full screen, because you want to be in the chat. All right, I'll think about that for next time. Thank you for that feedback. That's really useful. All right, so most of you have been putting B, which is correct. So if we have a look at this, this here shows the repeating unit of a polymer. So all we really have to do is shove a double bond in the middle to understand what the monomer is, because this is already showing us the repeating unit. So if we have that double bond in the middle and we kind of ignore these things here, then at this point we're just naming it. And we have, if we sort of do the thing that we're supposed to do when we're naming things, and we think about what the longest carbon chain is, the longest carbon chain goes from this carbon up here, up the top to this CH2, CH3. So would it be helpful if I drew this out because it's too small, or are we okay? Can I carry on talking while you guys give me feedback on that? Yes, okay. So I'm going to redraw this, but bigger so that we can see it properly. How do you know which way to start? It doesn't matter which end you start from. So you kind of just trial and error what the longest carbon chain is. But what you're looking for is you're just looking for the longest carbon chain. So as the first carbon has a methyl group and top and bottom, doesn't matter which one you start with. So this is still one carbon chain. If we follow along this bond, it's still a carbon chain. And if we go up to that CH2, CH3, that is also still a carbon chain. So we can see that the longest carbon chain here has 1, 2, 3, 4, 5 carbons, which makes it a pent. And we can also, then our job is to number the carbon chain so that our sort of substituent, so our methyl group, is on the lowest number. So we could either number from bottom to top or from top to bottom. So I could go carbon 1, carbon 2, carbon 3, carbon 4, carbon 5. And that would give us a 2-methyl pentene. Which is the correct answer, but I also could have chosen to start numbering from here. So carbon 1, carbon 2, carbon 3, carbon 4, carbon 5. But then I would have had 4-methyl pentene, and we always pick the lowest number. So we actually have 2-methyl pentene. And then I had a question for my face is in the way. Oh gosh. That's not helpful. No, I can't move it. I can't move it when it's on YouTube, but I can sort of draw this a bit lower. Can you see that? Yeah, you can. Okay, cool. What was the question? How do you know where the double bond is? The double bond, when you're given a repeating subunit, is always in between the two carbons in the middle that have the sort of carbony arms out the side. The bond arms. I think of them as arms. I don't know why I think of them as arms, but it's always in the middle of the repeating subunit. But I'm going to move on because most people seemed reasonably comfortable with that, but do let me know if you've got any questions. Okay, so this one's also bigger. So hopefully everybody can see this one okay. This question says, compound I is found in a biodiesel, and it has a skeletal formula shown below. So we've got this big compound here, and it says, why is compound I unsaturated? So here are, we've got about 1 minute. This font is a better size. Yeah. Okay. I'm used to doing these on Zoom where you guys can make it bigger, but you can't really on YouTube without losing the chat. So I will keep that in mind. Thank you guys. Yeah, I can see lots of you getting some good answers in there. No need for such a big molecule. I think there is a need in biodiesel. Okay, cool. Yeah, I mean, most of you've got it. The biggest problem is that lots of you said too much. It's only 1 mark, remember, so you don't really have to explain yourself that much. All you needed to say is that it contains a carbon-carbon double bond. So it's not enough to say it contains a double bond. It has to be a carbon-carbon double bond, but otherwise you're fine. So you could have just written the C double bond thing, or you could have said carbon double bond, like in words. Either is fine. Oh, thank you, Thomas. So Thomas has just said if you put it to cinema mode, you can make it bigger and keep the chat. So some of you might try that as well. You always say way too much or not enough. It's a skill. It's definitely a skill. And the way you learn how much to say is just by doing a bunch of them. So this is probably one of the best ways you can learn how much to say. So you're in a good place, other Georgia. Okay, cool. So the next part of the question says, a sample of compound I is shaken with aqueous bromine. What color change would you see? So you got like just under a minute to answer that one because there's not much to type. Where is cinema mode? I don't know. I can't open YouTube right now, but if somebody else wants to look for where cinema mode is and put it in the chat, I would be really appreciative. Getting lots of answers in there. Good. Organs. Organs to colorless. No, I don't think there are organs in this solution, Sad. Cool. Yeah. Or orange to colorless. All of you, almost all of you have got that. If you'd said orange brown, you'd probably be all right. But you kind of want to say orange, not just brown. Thank you everybody that's saying cinema mode is apparently on desktop at the bottom right next to the full screen thingy. Also my colleague has just dropped it in the chat. So thank you guys for that suggestion. All right, we're going to move forwards. Feel free to ask questions. So we all we all recognize that if we react an alkene with bromine, then the alkene becomes brominated, and then you end up removing the Br2 from the solution, and Br2 is brown, so then it goes colorless. So it's better to say orange or orange-brown. If you said brown, the mark scheme did not say brown, but a kind examiner would give it to you anyway because orange is really similar to brown, Maria. But it's safer to say like orangey brown. That way you kind of hit both sides. Yes, Jalaj says never say clear. Yeah, what you want to say is colorless. That is the functional group of this molecule. So here we have the alkene. If we added bromine, so Br2, I'm just going to draw this bit, not the whole thing, because that would be long. We would end up with an alkane with 2 bromines, and then the rest of this molecule. And that molecule is colorless. But the Br2 is orangey brownish. But yes, let us move forwards. So the next part of the question says cyclobutane is another cycloalkane, and there are several unsaturated isomers of cyclobutane that are alkenes. 2 of these isomers are stereoisomers. Explain what is meant by the term stereoisomers. Again, already getting some answers in there. You got another sort of 60 seconds. Have a go. And these are the kinds of definitions you just want to memorize. You hate drawing stereoisomers? We're about to have a go, so you'll get some practice. Okay, yes, lots of you got a beautiful definition, so I'm just going to write it in. We got the same structural formula, but a different arrangement in space. So you could have said different spatial arrangement or different arrangement in space or just different arrangement. Either is fine. And by structural formula, just to remind you guys, we mean like this one, like the CH2, CH, CH, CH3 thing. That's our structural formula. Okay, so the next part of the question is asking us to draw the 2 stereoisomers that are possible. So the first thing, do you need to also mention the molecular formula? So you do if you're trying to distinguish between stereoisomers and another type of isomer, but if you're just trying to talk about stereoisomers, you're kind of all right without the molecular formula, but it depends if what you're trying to do with the explanation. So if we're drawing our stereoisomers, what is the name of the stereoisomer going to be? So not like the distinction between the 2, just like what is it? So it's an unsaturated isomer of cyclobutane. So you guys are giving me the right kind of isomerism, but what is the actual, if it's a stereoisomer, sorry, if it's just an unsaturated isomer of cyclobutane, what is the molecule going to be? Yeah, it's going to be some kind of butene. And HH is right. It's got to be a butene, right? Because we wouldn't have EZ isomerism if it wasn't a butene. So what I'm going to do now is give you 2 minutes to draw them. And please do actually draw them. Don't just wait for me to draw them for you. It's good practice. Even when you think you know the theory, sometimes your brain just makes weird mistakes when you try and draw them if you haven't practiced. So just do that. I will answer your question in a bit. Let's give everybody a chance to draw, have a go at drawing these. You've got like 2 minutes. So if you don't have paper with you, go run and do that. Or if you have like a tablet or something, use like the drawing thingy-majig app. Ooh. think you got it, but the cyclo part's confusing you. That's fair enough. I will get to that. You're welcome, Pablo. I'm glad to be of help. Do you need to label it E and Z? Nope. The question does not require that, but we're probably going to do that at the end anyway, just to give you guys some practice. Okay. All right. Let's have a go. So I hope you guys have had a go at drawing it. So what we should have, the reason I sort of spoke about it before, because I didn't want you guys to be confused by the fact that it said cyclo. So remember, it says there are several unsaturated isomers of cyclobutane that are alkenes. 2 of these isomers are stereoisomers. So it's telling you that they're just normal isomers. So they don't have to be the same structural formula as cyclobutane. They're just isomers of cyclobutane. So they're just a butene. So you can ignore the cyclo bit. So everybody that was thrown off by that, remember to read the question really carefully, because if it's just like general isomers, they don't have to be bonded in the same way. They just have to be butane isomers. So what we have, we should have 2 of the alkenes, and as you guys said, they're going to be EZ isomers. So if I just start by drawing 2 carbon-carbon double bonds, and I'll name one A and one B. On A, what should the rest of my substituents be, and where should they be? Any ideas, lovely people? Yeah, there should be 2 CH3s and 2 hydrogens. So if we're talking about, yeah, so let's say I say this one is going to be the cis isomer / the Z isomer, and this one is going to be the trans / E. Should my methyls be on the same side or on opposite sides for the cis isomer? Same side or opposite side for cis / Z? Yeah, the same side. And that must of course mean that trans / E is on the, my methyl group should be on the opposite side. So do let me know if you have, no worries, Amelia. Do let me know if you have any questions about that. I'm going to address somebody's question earlier, was when do you use cis trans and when do you use EZ? So you can pretty much always use EZ. EZ is universal, but you can only use cis trans when the things that you're looking at, so the 2, so the groups, you have 2 of the same group. So for example, if this was a CH2CH3, I can no longer then use the cis trans isomerism. So you have to have the same group being on the same side or the opposite sides. Additionally, like for example, if I had bromine, chlorine, iodine, and hydrogen, this still has cis trans isomerism, but I would need to use EZ rather than cis trans, because EZ has the priority rules that allows you to deal with different groups, but cis trans requires them to be the same group. How can you tell quickly it's CH3 on each side? It's just because it's a butane, right? And the only butane that's going to have EZ isomerism is 2-ene, right? If it was but-1-ene, you would have, if it's like a primary alkene, sorry, so the alkene where the substituents are at the end, the double bond is at the end, then on one side you have 2 hydrogens. So it can't possibly be but-1-ene. It's got to be but-2-ene. What is the level of this class? So this is year 12 stuff. But the problem is that lots of the year 12s will have not covered some of their stuff, because obviously you stopped going to sixth form or college or whatever you, however you're learning your A-level before the end of the year, so you didn't finish your syllabuses. So if some of this is unfamiliar, it might just be that you didn't cover it yet. But all of this is year 12y stuff. All right, I'm going to move on to our last question before the end. So part A of the question, so we have but-1-ene, another butene, reacts with a reagent in the form of HY to form a saturated compound. Suggest a reagent of the form HY which reacts with but-1-ene. Can you not have C2C3H5? You can, but it won't exhibit any EZ isomerism or cis trans isomerism. So you're getting lots of different answers here. Some of them right, some of them a bit dodgy. I'm going to give you guys like another minute or so, or less than a minute, another 20 seconds to answer this. Yeah, it's always okay to call them EZ, as long as unless it asks you specifically whether it's cis or trans. Obviously, then you have to say cis or trans. But if it just says what isomer is it, then you can always use EZ. Okay, so I'm going to address the answers now. So everybody that said either HBr or HCl or HI, and nobody said H2SO4, but that was an option, was correct. The reason that you couldn't say H2 is because the form HY suggests you've got one hydrogen and then something else. So the Y should be something else. You also would need a catalyst with H2, which lots of you mentioned that you would need a nickel catalyst, but that's not sort of what we're talking about here. So because it's HY, the Y sort of suggests that it's not another hydrogen. How is H2SO4 in the form of HY? Namrata, I'm not really sure why it's in the mark scheme, but it is. It's not really, but it does sort of follow the same reaction they're looking for. So I assume they've just put it in there. Yeah, the HSO4 would act as the Y, but I would not have put that in there, but like it's in the mark scheme. But yes, HSO4 minus would be the Y. You also could not have said, I saw what other dodgy answers did I see? Yeah, you also could not have put H2O, because again, this doesn't say that there's any kind of catalyst. So you can't pick anything that would need a catalyst, and H2O requires either a base or an acid catalyst for that reaction. So because it doesn't mention one, you don't want to like put it in there just in case they're sort of saying this is the only reagent. But yes, so the next part of the question says name and draw the mechanism for the reaction in part A. So first of all, you guys can name it for me, and then again, you should already have some paper because we talked about that. So you guys are going to draw the mechanism, and then so I'm going to give you a couple minutes to do that, and then you're going to talk me through how I should draw the mechanism. So please, please, please actually draw it. practice is so important, especially with reaction mechanisms, because you lose marks for like the tiniest details. What's HY? So it's a little bit like saying HX, where you just mean Y is an unknown, but it's not H. It's something different. It's like saying 2x in algebra. I like electrophilic addiction. It sounds very interesting, Georgia. Okay, lots of people have said electrophilic addition, so I'm going to confirm that it is indeed electrophilic addition and give you a little bit of time to draw your mechanisms. All right, I'm going to get started. So we know that we have a butanene. So I'm going to go ahead and just draw that. And we've already sort of talked about butene, so I'm not going to sort of spend too much time asking you what butanene is. So butanene, I'm going to draw it like this because it's going to make it easier to draw the electrophilic addition, which is based around our double bond. So what is our electrophile in this? Let's say we just use HBr as our reactant. What is the electrophile? Is it the alkene or is it the HBr? Yeah, it's the HBr, right? Because electrophilic or an electrophile is something that is attracted to an area of high electron density, and our double bond is very electron dense. So when I'm drawing my HBr, what is going to, and also an electrophile is an electron acceptor, right? So what's actually going to be accepting the electron, the hydrogen or the bromine? Is it my hydrogen or is it my bromine that's going to accept the electrons from the double bond? So getting some different answers in there. It's the hydrogen. So if we remember our partial charges, we should have a partial positive on our hydrogen and a partial negative on our bromine, because our bromine is more electronegative than our hydrogen. You should check your periodic table and remember your trend if you've forgotten that bromine is more electronegative, which means, of course, that the partial positive has got to be the electron acceptor, right? Something partially negative is not going to be very happily accepting electrons because of the repulsion. So it has to be partially positive. So the hydrogen is going to accept our electrons. And my lovely colleague has just dropped a periodic table link in the description if you need to have a look at the periodic table to remember your electronegativity trend. So what we'll have is the double bond donating its pair of electrons to hydrogen. And it's really important that you draw the curly arrow going directly from the double bond, where the electrons are coming from, to the hydrogen. If you were to draw it from the double bond to the hydrogen-bromine bond, you would not get your mark. If you were to draw it from the double bond to the bromine, you would definitely not get your mark. If you drew the curly arrow starting from the carbon, instead of the carbon-carbon double bond, you would not get your mark. You must be really careful to show exactly where the electron is coming from and where it's going to. And in this case, it's coming from the double bond to the hydrogen. So that's our first step. And then lots of people have been saying then we have another arrow going to bromine, which is correct. So once the electrons are donating to that hydrogen, the electrons in the hydrogen-bromine bond are very much repelled. And we know that bromine is electronegative, so it's going to be pretty happy to receive a pair of electrons. So the hydrogen-bromine bond breaks. So the electrons from that bond, so our curly arrow starts there, go to the bromine. So again, you must draw the curly arrow exactly from the hydrogen-bromine bond to the bromine, nothing else. So you can't draw it going from the hydrogen to the bromine. It must be from the hydrogen-bromine bond to the bromine. And I know I'm like drilling this in, but so many students do not understand how accurately they must draw these diagrams, and then they end up losing marks. So that's why I'm being so pernickety. So that's our first step. We have then got carbon that has formed, I should say, a bond with a hydrogen. And what does that mean our intermediate species is? What kind of species is this intermediate? What's important about it if it's only formed? Yeah, it's a cation, it's a carbocation, right? So is our positive charge going to be on the left carbon or the right-hand carbon? Is it going to be on the left or the right, the positive charge? Yeah, it's going to be on the right, predominantly. So there will be a small amount of these molecules in the reaction chamber that ends up on the left, but most of them will be on the right. Why does that matter? Someone tell me why it matters that the positive charge is on the right and the hydrogen is on the left in this case. Why does it matter? No worries, Namrata. Yeah, a secondary cation is more stable than a primary cation. And what we mean by that is something that's more substituted with other carbons. The carbon that's substituted with the most other carbons is going to be the more stable carbocation. And it's easier to understand it in terms of electron density, right? So if this carbon here has a positive charge, all of the electrons around the CH2 and CH3 can sort of like lend into that. So that yellow box is going to represent my electron density, right? But if, for example, I had the positive charge on my left-hand side, hydrogen, if you guys remember, only has one of its own electrons. It's got very little electron density to sort of like lend over to stabilize that positive charge. So it's just quite unstable. So the more carbons you have, the more electron density you have to sort of drag into that positive charge and like stabilize it a bit. And the less other carbons you have attached to the carbocation, the sort of more unstable it is. Hydrogen is rubbish at donating electron density. Would you lose a mark for the left-hand positive charge? So this question did not specifically ask for the major product. So for this question, you would probably be all right, but the part C to this question asked which was the major product, but I've sort of like shoved them together just because we won't have time to do both parts. So if it asked you what the major product is, this is your major product. Yes, these are called inductive effects on some of the exam boards, and some of the exam boards are called electron donating effects. Would the question state if it wanted you to draw the mechanism and form the major and minor products, or would you always assume the major mechanism? So I would always assume the major mechanism, but most likely if it doesn't state that it wants the major product, they probably won't penalize you because some of the minor product is formed, so it's not incorrect. But there is a part C to this question which we're not doing that asks you which is the major product, so I'm just shoving them together to save time so that you guys get the most content all in one go. I wanted to sort of cover both. You could draw both mechanisms, but it might waste a bit of time in the exam. You could go back and draw both if you have time at the end, I suppose. Okay, so we have a positive carbocation, and we also have our bromine, which of course must be negatively charged. So what's going to happen to that carbocation and that bromine? Anybody want to help me out with that? What's sort of the last step of this? Yeah, it's going to bond. Why specifically bromine? I just randomly picked the HBr. It could have been HCl, could have been HI. I just picked HBr. Yeah, so exactly. So Namrata has said sort of the most important thing. We must, at A level, not at degree level. At degree level, you'll be fine drawing the curly arrow from the negative charge. So if you happen to be not an A-level student, you don't need the lone pair. For A-level, the mark schemes always ask you to draw the lone pair, even with a charged species. So you want to show the curly arrow going from the lone pair of electrons on bromine to the carbon double bond, because remember the movement of electrons is always going to go from the electron rich place. The arrow is always going to go from the electron rich place to the electron deficient place. So that's what our last step is going to be. And then we have a nice bromoalkane as our product. And I have to leave it there because, as usual, I did not finish within the 45 minutes that I allotted myself. So I am apparently terrible at timekeeping on these YouTube classes. Okay, thank you for sticking with this. I hope it was helpful. Feedback is always welcome. So if there's something you'd like us to do a little bit differently, I mean, like we do these for you. So if there's stuff that you want me to do differently, I'm totally happy to do that. So as usual, I'm going to sort of like quickly walk through our website, because that's like part of the reason we do these YouTube sessions, to sort of let the world know about the kind of thing we do on our website. So if you haven't seen that, please stick around, and then I'll give you the code for a discount afterwards. I'm glad it was helpful. So thank you for the feedback. So I'm going to show you the website. If you've already seen the website, obviously you don't need to stay. But yes, I shall share my screen with you so that you can see it. Where am I? Okay, so the website automatically tells you about the YouTube live streams. So there is the live stream thingy. But as you can see, we've got other live classes on our actual website that are live right now. So there's one, biology is running one, enzyme controlled reaction practicals, the maths, A-level maths drop-in is happening. So that's sort of like the general stuff that's happening like right now live. But we've got all sorts on here. We've got sort of like courses for your exam board. So let's be edXL today, because I always seem to pick a QA. So we have sort of like this dashboard, and you sort of can mark your progress throughout the course, and like scroll down to the thing you're having problems with. So I'm going to randomly pick crystal structures. And you would first do a diagnostic quiz to sort of figure out how much you know, how much you don't know. And then we would sort of like push you to the videos that you may sort of learn the stuff that you need to learn. And you can skip ahead to different topics. So let's say you just want to be able to draw the hydrated formulas. You could skip ahead to that, and then you do a quiz to see if you sort of know everything, and then you can watch an exam question run through. So that's sort of on our most basic package. You get all of these videos for all of the content, so which is probably quite useful if you're at home trying to study by yourself. And then if you're on the next package, we have all of these exam questions that we've come up with. So I know that lots of people have a problem with running out of exam questions to practice. So we've got just like loads of them, and then you get to see the solutions for them and mark them yourselves. So that's really useful for some people. And then we also have, if you have the ultimate package, as I always say, you get me. So I'm going back to my dashboard for chemistry. you can click on web classes and have a look at, so for example, in about 4 minutes, my God, I need to hurry up. We're doing a green chemistry class. So we're going to like recap our addition polymers, talk about different environmental impacts of polymers and things, the stuff that's on the syllabus. So that's the class that's happening. And there's loads of classes as well. So there's a book club where we're reading about quantum mechanics a bit. And as I mentioned earlier, personal statement writing workshop that we're doing once a week as well. And we also have drop-ins where you basically just ask me whatever you like and I help you go through it. So that is our website. Ta-da! And this time I'm going to remember to give you the code for the subscriptions because I remembered this time. So this is the code. Actually, remember to sort of set reminders for the study clubs on YouTube, by the way, so you don't forget. And this is the code if you want £10 off the subscription. Can you first give us an explanation and then go through the question? Do you mean of the entire topic? So like do it as like a class rather than go through questions? Is that what you mean, Fassi? Because we have done setups like that before in the past. But yes, this is the code. Thank you for sticking around, those of you who are still here. You know, tell your friends about this if they need a little bit of help. The free ones on YouTube, so they're accessible to everybody. But I'm going to finish off because I really need to prep for my next class, which is in 3 minutes. So I'm going to go. Have a lovely, lovely, lovely afternoon. It was great to have you.